guys should have a graph. Does everybody have a graph?
Yes.
Okay. I pointed out one thing yesterday when we were doing the graph. Did anybody notice that yesterday, this right here, let's look at this one right here. This is a typical S curve. This is a titration, an acid-base titration. Can you tell me what kind of acid-base titration this is?
Strong.
This is a strong acid, strong base titration. Does that make sense? You started down low, you ended up high. Strong acid, strong base titration starts low, ends high, and it has a really long equivalence point. And the equivalence point is at what? 7. Okay? Yesterday's, the graph that you have right there, you started up a little bit higher, right? Like around here. And then went something like that.
Yeah.
Why? Because it was a weak acid.
Why is this bouncing so much?
Earthquake.
So it's a weak acid, strong base. So notice I end up at the same point. Okay? Notice that its equivalence area is a lot smaller, and it's also what? Higher. See how it's higher than 7? And that's why we used a different indicator yesterday. We used phenolphthalein. Does that make sense? Okay. All right. What would this represent right here? Strong acid, weak base. And a strong acid, weak base titration also has a smaller equivalence point, and its equivalence point is lower than 7. Okay? There's one more. What would that be? Weak acid, weak base. Where's its equivalence point?
7.
Yeah, that one is at 7. Does that make sense? So you guys should be able to start recognizing things from various graphs. Okay? For example, this one right here, look at it. Look at it. What kind of graph is that? Strong acid, strong base. Now yesterday we talked about one where you started with the base and you were titrating it with an acid, so it looked like this. Okay? Alright, what about this right here? This is showing you a strong acid, strong base. This is showing you a weak acid, strong base. This equivalence point will be at 7. This one's going to be a little bit higher. What is this showing me? Starting way up here at 4, right? Weak acid, weak base. Okay? What is this showing me?
Strong acid.
A weak base, strong acid.
Weak base,
Oh.
strong acid. So notice my equivalence point is below 7. Okay? What is that showing me?
A squiggly line. Showing you our graph.
Acid and weak acid, and then more of them.
First of all, what kind of base?
Strong.
Strong base. What kind of acid?
Weak.
Okay, weak.
Diprotic.
Diprotic. Thank you. It's a diprotic acid. Diprotic acids give off how many hydrogens?
2.
Here's one. Here's the other. Does that make sense? What would triprotic look like?
3 of them.
3 humps, right? Okay. Good, good, good. All right. There's only one more thing that I want to show you. Sometimes they look like this. And that typically is when you're titrating a buffer. What's a buffer? It resists change in pH. And this right here is called your buffer zone. This is where it's trying to resist that change in pH. And then eventually it's got to give up, right? Eventually you're going to run out of all your chemicals and it goes. Okay? All right, good, good, good. Here we go. Let's start the new hard stuff. Please whip out titration practice. We did this yesterday. We did number 1. We are on to number 2. All right. Number 2 says a 35 milliliter sample of 0.15 molar acetic acid is titrated with 0.15 molar sodium hydroxide. Calculate the pH after the following volumes of base have been added. So what kind of titration is this? Weak acid, strong base. Very, very good. First thing I want you to do is this. Write the reaction out. The balanced net ionic equation. HC2H3O2 together, right? You don't break it down. How do you write down a strong base? OH negative. Okay? What do acids do? Give off H. What do bases do? Take in H. So what does it look like? This plus OH. This H comes over here to make water, and then I'm left with acetate. Okay? Does that make sense? Alright, so here we go. A. What is the pH before or when you add 0 milliliters of sodium hydroxide? I'm going to need you to move with me on this one. So that means that all I have is just acetic acid. Remember doing this stuff right here? H positive and C2H3O2 negative. And then we can write a Ka expression for this. What would it be? H positive times acetate, which is my conjugate base, over HC2H3O2. Do you remember doing this? Ka is equal to x squared over concentration. And when you solve for x, what is it?
Hydrogen.
It's hydrogen, right? So everybody remember all of this?
Yes.
So look at the question again. It says, what is the pH when you add no sodium hydroxide whatsoever? So all you have is your acid. Do you have Ka?
Yes.
Do you have concentration?
Yes.
Solve for pH. 0.0016. And that's my molarity of hydrogens. When I press negative log number, my pH is going to be, is it 2.80? That's what I have. Okay? That should not be anything new. That's like last chapter. Okay, are we cool?
Yeah.
Ka is x squared over concentration. Okay. Alright. The next one, well, what's the pH going to be after you add 17.5 milliliters of sodium hydroxide? So now we're going to have to fill out an ice chart. And when we do the ice chart, we have to fill it out with what?
OH.
Moles. Not molarity, moles. So here's what I want, and I went over this 2 days ago. Solve for the number of moles of acetic acid right here. Moles. Okay? Now solve for the number of moles of base. 0.002625, is that correct?
How did you find that one?
I took 17.5 mils,
Okay.
right? Which is
Oh, okay.
0.0175 times 0.15.
Yeah.
Alright, I understand that up here I did not follow sig fig rules. It's just for B. Just for part B, I want to show you this. There's something special about part B that I want to show you, so I'm not going to use sig fig rules, okay? So just bear with me on that. I'll go back to sig fig rules. I know you guys love sig fig rules. Okay? This is what? Zero, that's right. It's a product. It hasn't happened yet. So, who do I have more of? I have more acid than I do base. So who am I going to use all up? I'm going to use all of this guy, 0.002625. Lose 0.002625. Here I'm going to what? Gain 0.002625. So this is 0.002625. This is 0. This is, somebody do that math for me. 0.002625. Okay, okay. Moles. Alright. What's my new volume in part B?
17.5
Well, 17.5 plus the 35, which is that 52.5?
Yeah.
So I'm going to divide it by 0.0525 liters. 0.0525 liters. Okay. And somebody go ahead and do that. And this time you can give me 3 sig figs.
0.050.
050, is that what you get?
Yeah.
Okay. And then over here, 0.050. Okay? Is everybody cool so far? Alright, now watch. Ready? Lucas, you ready? Might be. Okay. This is the molarity of that. This is the molarity of that. That's my weak acid. That's its conjugate base. Don't you think an acid and a base influence the pH?
Yeah.
Okay? So all I'm going to do is this. Watch. Ready? I'm going to use this thing. Don't I have Ka?
Yep.
Do I have this?
Yes.
Do I have that?
Yes.
Can I now solve for H?
Yes.
And then press negative log number?
Yes.
Please do so. Wait, did you notice something? Isn't this the same as this?
Wait.
Yeah. This is the same as this.
Right.
So what can you do? Cancel them. This is something special right here. Okay? And therefore H equals this. Therefore I just press what? Negative log number. What do you get for pH?
4.74.
I've got 7.4. Does that sound right? Okay? I want everybody to write this down somewhere. This is something special right here. This is halfway to the equivalence point.
That equation?
You see this right here? Isn't this half of that? So that means I'm halfway to the equivalence point. Everybody stop. Eyes up here. When you're halfway to the equivalence point, this will always equal this. And you can cancel them out.
So you're
Okay? And what that means is, if you're halfway to the equivalence point, then H equals Ka. And pH, therefore, equals something called pKa. And by the way, all P is, it just means negative log. Moving on, here we go. Everybody look at the next one. We are on to C. Everybody look at C. So I want to know now, what is the pH when 34.5 mils, 34.5 mils of sodium hydroxide is added? So here we go. Isn't this still 0.00525 moles?
Yep.
Okay. Find out how many moles of hydroxide I have in part C. Find out how many moles of hydroxide I have in part C. Alright, and this is 0, correct?
Yeah.
This side's going to gain, lose, lose. This is still the lowest number, so 0.00518, 0.00518. I'm going to gain 0.00518. Okay? This is going to be 0. This is going, somebody do this math. I don't think I have that one. That's like, is it 7 times 10 to the negative fifth? And then this is 0.00518. What is my new volume in part C? It's 35 plus 34.5. Is that 69.5? So I'm going to divide by 0.0695. Divide by 0.0695. And tell me what your molarity is with 3 sig figs. I've got, is it 0.00101?
Yeah.
And then over here I have 0.07. Alright, here we go. Watchy watchy. That is this. That is this. So I'm going to go back over here. I have Ka. I have this guy, I have this guy. I simply solve for h. And then when I solve for h, I press